Adaptation is the process of adjustment to current or expected changes in climate and its effects. U205, U200 without additional mitigation. Adaptation cannot avert the risk of severe, widespread and irreversible impacts. More severe climate change requires more transformative adaptation, which can be prohibitively expensive. The capacity and potential for humans to adapt is unevenly distributed across different regions and populations, and developing countries generally have less. The first 2 decades of the 21st century saw an increase in adaptive capacity in most low and middle-income countries with improved access to basic sanitation and electricity. But progress is slow. Many countries have implemented adaptation policies. However, there is a considerable gap between necessary and available finance. Adaptation to sea level rise consists of avoiding at-risk areas, learning to live with increased flooding and protection. If that fails, managed retreat may be needed. There are economic barriers for tackling dangerous heat impact. Avoiding strenuous work or having air conditioning is not possible for everybody. In agriculture, adaptation options include a switch to more sustainable diets, diversification, erosion control and genetic improvements for increased tolerance to a changing climate. Insurance allows for risk sharing, but is often difficult to get for people on lower incomes. Education, migration and early warning systems can reduce climate vulnerability. Planting mangroves or encouraging other coastal vegetation can buffer storms. Ecosystems adapt to climate change, a process that can be supported by human intervention. By increasing connectivity between ecosystems, species can migrate to more favorable climate conditions. Species can also be introduced to areas acquiring a favorable climate. Protection and restoration of natural and semi-natural areas helps build resilience, making it easier for ecosystems to adapt. Many of the actions that promote adaptation in ecosystems also help humans adapt via ecosystem-based adaptation. For instance, restoration of natural fire regimes makes catastrophic fires less likely and reduces human exposure. Giving rivers more space allows for more water storage in the natural system, reducing flood risk. Restored forest acts as a carbon sink, but planting trees in unsuitable regions can exacerbate climate impacts. There are synergies but also trade-offs between adaptation and mitigation. An example for synergy is increased food productivity, which has large benefits for both adaptation and mitigation. 2 examples for trade-offs include: firstly, the increased use of air conditioning allows people to better cope with heat, but increases energy demand. Secondly, more compact urban development may lead to reduced emissions from transport and construction, which is good. But at the same time, this kind of urban development may increase the urban heat island effect, leading to higher temperatures and increased exposure of people to heat-related health risks.